Welcome to the Cyber Insecurity channel and another study session Tuesday where we're focusing on Intro to Python. My name is Brent. I was a software developer for 6 years, computer science professor for 17 years, and now I'm a threat intelligence analyst. So I've programmed everything from shell scripts to a custom network server to simulations that run on supercomputers. So I have lots of experience making programming mistakes and then helping people learn to not make the same ones and completely new mistakes. So thanks for joining us tonight. If you want to connect with me on socials, you can use !Brent to see all my socials. I do ask that if you want to connect with me on LinkedIn, that you put a note with it and tell me what you're hoping to get out of the study sessions. Thanks again for being here. Sorry we had to miss last week. The power supply on my computer decided to die, and so my computer would randomly shut off after about 5 minutes or so. So I didn't think that that would be a good way to do a stream. So we had to hold off while I got a new one. So thanks for joining us tonight. I want to thank our moderators for being here. We have a zero tolerance policy on toxicity in the Cyber Insecurity channel. We want this to be a positive learning environment for everyone, and moderators are here to ensure that happens. If you are put on a timeout or a ban, talk to the moderators about it in our Discord. I don't have any control over that. So moderators are not here, however, to stifle chat. They're here to ensure you get an opportunity to learn and ask the questions you have so you can better improve your knowledge and be able to learn Python. So I welcome questions throughout the study session, but we do have a few rules. First, ask your questions once and only once. The moderators do see your questions and will send them to me. I'll try and answer them as quickly as I can. Depending on the content and the flow, if I'm going to be answering your question later on, I'll just kind of hold on, but we do see your questions. Second, there are some questions I just can't answer on stream, so I can't get my program to work. Can you take a look at it or something like that? It's just not really viable for the live stream. However, we do have the Discord channel, Intro to Python. You can hop in there, post code, so if it's during the stream, there's people that watch that and will help you. If it's afterwards, people will also be able to help you, and I can jump in and provide some feedback. So please ask questions. One of the things when I was in the classroom, I urged students to ask questions, and it seems like in recent years, students were really afraid to ask questions. So please don't do that. That's how you learn. Just as a reminder, this series is based on content from my University Intro to CS course. It's the same content that was in there. We don't have any prerequisite knowledge for any of this, but we are going to be using some basic math, and we'll be doing some of that today. So focusing on easy to define problems, there's a GitHub repository that has all our learning materials. You can do !Intro to Python and get access to all of that. It's got notes, some exercises, and even a link to the book we're using, Think Python. So it's a free download, or you can buy it from your favorite bookstore. So if you've been following me on Twitter, you've seen that I've posted a algorithm of the week. So kind of an idea to kind of get the juices flowing and think about problem solving. And as a reminder, each one of the algorithms I post, if you're going along with us and you don't know Python, you don't know enough Python at this point to complete the problem in code. That's intended. The idea is that you can focus on the problem-solving aspects while we learn Python. So let's look at the algorithm for this week. So this week the algorithm was to sort a list of numbers from lowest to highest. One of the things I find is that this is pretty easy conceptually because we do it, right? In my data structures course, I would hand students a deck of cards and have them sort it. Everybody knows how to sort it. But then again, it's defining all of the steps. So students have a tendency to kind of gloss over this because it's one of those, you know what I mean. So let's kind of dive into it and work on some details. Now, before I get started, there are a number of sorting algorithms you can use. Some of them are really simple and inefficient. Other ones get more complex and more efficient. So if you had a different algorithm, that's fine. There isn't a correct answer in here as long as you get the correct sorted order. So I'm going to use a very simple one called the selection sort. If you know that one, it's probably one of the most basic ones. So let's dive into it. So again, this is a very simple problem. So I'm just going to take the problem statement we've got here and use that for the problem. Now, again, this is a simple example, but if you get in the habit of doing it, when we do some more complex ones, like the exercise we're going to be doing here in a little bit, then that will be of great benefit to you. All right, so we just want to sort a list of n numbers. N basically is a placeholder, so we can say we don't know how many there are to begin with, and it can handle any number of them. So preconditions, this is what's the situation of the problem before we get started. So what we have here is we have a precondition, a list of numbers. And this may seem kind of simple and silly, but it's important. So for example, we know it's numbers. So it's not numbers and letters or numbers and other things. We know it's all numbers. So we can use basic mathematical comparisons. We know we've got a list. Now, one of the questions we do have in here is, what's a valid value of n? So we know it can't be negative, right? Because I can't have a list of -3 numbers. That really doesn't make sense. But can we have 0? Well, that's a good question. Now, usually in computer science and programming, we allow lists of 0 length, right? So if I have a to-do list and I accomplish everything on that to-do list, I still have a to-do list. It's just empty. So we can decide what we want to do on here. For simplicity, to kind of avoid some of the simple cases, we'll say that there is at least 1. Right now, in general, we won't do this, but for the sake of this example, we'll go ahead and do it. A postcondition is that we have the same list of numbers. It's just the order has changed, so it's from lowest to highest. Now, we didn't say anything about this in the precondition, but you could have already received a sorted list, in which case you just return the same one. So we have a list of the same numbers now in sorted order from lowest to highest. And again, if the precondition isn't met, we aren't required to meet that postcondition. So if we're given a list of letters and numbers, all bets are off. We can actually fail and we're okay because they didn't meet the preconditions. All right, so let's kind of step through an algorithm. Again, if you came up with something different, as long as it works and you haven't skipped any steps, you're good. So first of all here, let's see step 1. We can do a couple of things. So we're given a list. So I'm going to create a new empty list. So I'm going to actually sort these and put these in a new list. Actually, let's go back. We'll do this in the same list. So what we want to do, we're just going to start off here, and there's a couple of different things. So what we can do is say, in the selection sort, I want to find the smallest number in here. Okay, if we were sorting from highest to lowest, we'd look for the highest. So we can say start at the first number. Okay, and I'm going to just call it the smallest so far, right? So we could do a variable name when we get into programming and just call it smallest, but for right now, we'll call it the smallest so far. Then step 2, we could then, I'm going to use a term we're going to see tonight called iterate. So it basically means kind of walk through the list. So I can iterate through the rest of the list and look at each number, right? And then in here, we could check to see, is it smaller than the current smallest so far? So if we start off and the first number is a 7 and the next one is a 4, we can check to see, all right, that one's smaller. So let me put an example up here real quick of some numbers. So we're going to do 4 and then 42, 55, and 13. So we can run through an example. It's always good to have an example in here. So for example, we would start at 7, then we'd go to 4, And if it's smaller, then this number becomes the new current smallest so far. All right. So in this case, we're at 7. That's the smallest so far. We look at 4. It's smaller. It's the new smallest so far. And then because we're iterating, we're going to go through the rest of this list. So we're going to look at 42. It's not smaller than 4. 55 is not smaller than 4. 13 is not smaller than 4. So we've reached the end. So now this new one, what we can do is we can take this new current smallest number and move it to the front. All right, so we could swap it with the first thing in the list. So we can do this. So swap the current smallest so far with the first item in the list. So what we would end up with after this first one is 4, 7, 42, 55, and 13. All right, so we're one step through the process. And if we look at it, that we've got just this list here, this is now sorted. And so then what we look at is we're going to look at this rest of the list. And so then we can say something like move to the next position. So in this case, it would be 2. And we can like view our list as now the 7, 42, 55, and 13. And then we can say, call this number the smallest so far. And then we can say something like, go to number 2 right here. And so it iterate through the rest of the list. So we look at 7. So we start off with 7, then we can go to 42, then 55, then 13. None of them are smaller. So now we move that to the next place. It's the same one. And then we can go on to 42. We look at that. We'll go on. We'll find that 13 is smaller, so those will swap. So what the list would look like in the next one would be 13, 55, and 42. All right? So we can go through all of this, and there's many opportunities to improve this, but the idea here is that the point is, can we walk through this entire example, and does it work? So California has a question, does this work with decimal values? And so all of these sorting algorithms are based on comparisons. And so this is the only part right here that actually cares what the data is. And as long as you can compare them and say one is less than another, then it works. So in this case, does it work for decimal values? Yeah, because you can compare decimal values one less than another. You can do characters and strings, which we'll talk about later. If you want to get more complex things and compare them, you could. So for example, when we make chocolate chip cookies, one of my kids likes more chocolate chip cookies and the other one doesn't like a lot. So we could order our chocolate chip cookies on the number of chocolate chips. Now we would have to define how that comparison works, but as long as you can compare two items, then that's great. Then these sorting algorithms work. And so as you get more involved in programming, this comparison is the big thing. And you can actually dive off into the deep end, into theory, and talk about computational complexity, and it's all based on that comparison. Right? And I do want to shout out, thank you to Zachary Buga for a new member of Narwhal Prime. So as I said, this is, not necessarily a complete algorithm. So we could, it's complete in that it'll go through the process. There's a lot of opportunities to clean it up. But the idea is we're not necessarily going to get it perfect the first time. Do we walk through it? Can I go through each one of these, end up with something sorted, and am I not skipping steps? That's the important thing. You don't want to skip steps because that's where problems come in when you start moving this into code. Because you skip the step in the algorithm and then you get to the code and it's like, okay, now what? All right. So there's an example. Again, I put on Twitter. So this next week, if you want to put it on Discord, I can put it up here using it as an example. We can talk about it. Don't worry, I won't trash it too bad. So former students of mine know that I can provide feedback is the way I call it. So with no more questions, let's dive into Python. So if you remember from the last stream, we ended on chapter 3 where we were talking about functions, and I gave you a take-home assignment. So I said that there is an app store, like for your phone, and he was building an app and wanted to know how much to price it. So wanted to say, given the purchase price, compute the profit earned on app purchases. So I gave you a couple of examples that he did some trials. So for example, he priced it at $2 and got 1,000 purchases, and $3 and got 700 purchases. And there's some known data here that there's a refund rate of 5%. So 5% of all the purchases, people say, no, I don't want it. And so he has to give that money back. And then all the transactions, the App Store takes 50% off of it. So whether he prices it at $2 or $3 for every purchase, he has to give 50 cents to the App Store. So that's going to eat into his profits. All right. So there's a number of ways you can do this. There's someone on Discord that put up a solution, and I asked them to redo it a little bit. Not that it was wrong, but I wanted them to work on something. So if you came up with a different solution, again, as long as it works, that's fantastic. The idea here is, does it work? And I'm going to kind of go through it a particular way because there are some points I want to illustrate. All right. So let's look the way I'm going to kind of do it here. So we're going to start off. I'm going to define a function called calculate profit, because the whole problem here is I want to calculate the profit. All right. So calculate profit, and I am given a price. So we've talked about the parameters. So I have a price here. Now, we have to figure out how this is going to be done. So this is kind of the algorithm development part. So for those of you who don't know, profit is the revenue, how much money you take in minus the costs. So I can put in here as a comment, profit is revenue minus costs. So I'm going to create just a variable here real quick. I'm just going to set it equal to 0, just as kind of a placeholder. And then I can say return profit. And so the idea here is I can test this if I wanted to. So I could say test profit, calculate profit of 2, because that's one of my examples here. And then I can print out profit at $2, and I'll show it here. Test profit. All right. Now, if I were to run this, it returns 0, right? So pretty simple, but it compiles, which means it works, right? So let's step through. So if profit is revenue minus costs, then I need to have a way to calculate the revenue and calculate the costs. All right. So I don't know how to do that yet. So let's create some functions that do this for me. So calculate revenue, and this is not going to compile at the moment, but I'm going to put question marks here. And I don't know how this is going to work, but I do know that I'm going to have something in here called revenue, defaulted to 0, and then I can return revenue. So if I were to call this, I don't know what I'm going to pass here. Revenue equals. And then I can do the same thing with the costs. All right. So this approach here that we're using is called a top-down approach. I'm starting at the top, the high-level profit, and working my way down. You can also think of this as something like, I've heard it referred to wishful thinking, kind of like I wish I had a function that did this for me. All right, and then we'll go ahead and start working on that. All right, so I can do the same thing here. Costs, don't know. Now, I can't compile this and run it because I've got question marks in here, but I've got an idea of what's going on. All right, so let's go back up here and calculate revenue. So if we want to see how do we calculate revenue, right? Well, revenue in this case is the price we sell the app for, and then how many are sold, right? So if revenue equals purchase price times number of purchases, all right? So if I want to do that, then I need to have a variable called price. Well, if we look, I've already got the price, so I can use that to pass it in here. So I've got the price, so I at least know that's where this price comes from. And then I've got the number of purchases. So I'm going to have to figure out, calculate the number of purchases. So number of purchases equals 0. And so now I can calculate revenue is price times number of purchases. All right. Now, notice that at this point, we can't actually run to calculate any of this, but we're just kind of working through. In fact, I could have left off all the Python code and just left the comments in here, but I wanted to make this go a little bit quicker. But if I were developing this kind of on my own, I'd do all the algorithms first to make sure I understand what's going on. All right. So now we've got an idea of how to calculate the revenue, but we still have to figure out how to calculate the number of purchases. So I'm going to go ahead real quick and calculate number of purchases. And we have to figure out how to do that. Well, we do know that if it was priced at $2, we had 1,000, and $3, it was 700, right? And I say assume a linear relationship. So let's put some of this information in here and see what we can figure out. So we know that $2 gives us 1,000, and $3 gives us 700. So if we wanted to, we could just, since I say assume a linear relationship, so here's some math, it makes things a little bit easier, trust me. We can simply use the equation for a line. And that is the old y equals mx plus b, where m is the slope and b is the intercept. And so if we throw some of these in here and work it out, I'm going to save you having to do the math. So if we work in these data points, we get m equals -300 and b equals 1,600, where y is the number of purchases, right? Because that's the dependent variable, and x is the price. So if we write this out, we could say number of purchases equals, we follow this mx plus b, so this is the y, we have -300 times the price plus 1,600. All right. Now, we definitely want to test this, right? I don't want to go any farther. So to test it, we need to know what an input, valid input would be, and what a valid, the matching output would be. Fortunately, we have it right here. So what we can do is we can test this. So let me make sure I return number of purchases. And so we have test number of purchases. And if I lose you, please let me know. Again, there's an equation for a line. You don't really need to know that at this point. It's not crucial to the Python part. It's just, it's a simple way of doing some math here to calculate the number of purchases. So I'm going to just use the price because we know that that's all we have to have. So if I pass in 2, the answer should be 1,000, right? Because that's what our problem told us. So I can say print num of purchases, $2 should be 1,000. And then does that equal what we get out? So I can say test number of purchases. All right, so let's run this and see if it happens. Oh, it still doesn't like my invalid syntax. So I'm just going to put in, since we've got here, I'll just use X, the unknown. All right, X is not defined. Oh, I'll pass in 0. Okay, so we go back up here, number of purchases. We got 1,000, which is what we thought it should be. So let's try it at 3. And for 3, we should get 700. All right, so we've got 3 and 700. So let's try this. All right, so we got the right answer for those 2. Now, I want you to urge you to be cautious here. We have not proven that this works. We've used 2 examples. This is not proof that it works. What this has done is this has given me confidence that I'm on the right track. All right. So it's not a proof, it's just confidence, right? The only thing we could say to prove it is we tried every number, which we're not going to do that. But the more test cases we have, the more confidence we have it's correct, right? It could be wrong for $2.50, right? But we're going to go as it's correct at this point. All right. Why are you using 1600? It gets back to the equation of a line. So I can throw this up here. So this is some basic math stuff for algebra that I didn't really want to dive into. But if we have our 2 points here that we have y equals mx, mx plus b, we know 2 data points. So we know 1,000 equals m, actually it's 2m plus b, and then 700 equals 3m plus b. And so what we can do is we can do some algebra here and move things around. So we end up with b equals 1,000 minus 2m, and it also equals 700 minus 3m. And so then what we can do is we can move some stuff around and figure out A and B. All right, so it works out. So we solve this for m, and then once we have m, we can put it in and we get the b. So if you'd like to dive into this more, I'm happy to do it off stream. I don't want to. There's a reason I was not a math professor. So we'll use the bare minimum of math to do a little bit of stuff. So, but again, if you have a question, I'm happy to go through this at another time. All right. Okay. So calculating revenue. We know that to calculate revenue, we need the number of purchases times the price. Well, we have a function here that can calculate the number of purchases. So I can do that. And all I need to do is pass the price in. So now we can test calculating the revenue. So we've got test revenue, and I want to calculate revenue for $2. How much money will we get in revenue for $2? So let's think about this. If we'll get 1,000 purchases at $2, so we should get $2,000. All right. Whoops. So let's check this. So I'm going to print revenue for $2, and it should be $2,000. And so does that equal test revenue? So let's run this. We got $2,000. So we've got confidence that it's right now. Let's try it with the 3. So if we do $3, we've got $3 at 700 purchases, so that should be $2,100. All right, so let's try this here real quick. See if this works. We've got that, so we've got some more confidence. All right, so we have a question from MacGyver. In the number of purchases, does it automatically do PEMDAS? So yes, Python follows PEMDAS, meaning it will do the multiplication before it does the addition. Now, if you do something complicated, I'm always a fan of putting parentheses in there liberally. So if you are concerned at all that it might not work, you can put parentheses in there and force it to do the order that you want. So I'm all for not trying to be too smart, because usually when you try and be too smart, you fail. So there's an adage that says debugging a program requires 50% more intelligence than creating it in the first place. So if you use all your smarts to write a program, by that definition, you're not qualified to debug it. So I try and write it as simple as possible because debugging is a pain. So if you're at all concerned, put parentheses in and force it. Okay. So, but yes, it does follow PEMDAS. All right. So we went through calculating revenue for $2 and $3. Notice that I did the prediction before I ran it, because if I ran it and then said, oh yeah, that matched my prediction, sure, it probably didn't. I was just guessing and being lazy. So, which is good for a programmer, but not in this case. So again, we've got some confidence that this will work. Now we have to figure out how to calculate the costs. So there's a couple of things that we've got to worry about with costs. So our costs, we have a transaction rate, or a transaction cost. So for every transaction, we give the App Store 50%. And then we actually have to subtract off, because 5% of the total number of purchases are refunded. All right, so both of these are going to require calculating the number of purchases. Now, this is where the benefit of functions come in. You know, you can say, I wish I had a function that calculated the number of purchases. Well, look here, we just created one. So what I've done is I've pulled out this code into one function so I can reuse it. And it also means I only have to get it right once. Right? So I'm going to do the same sort of thing. I've got to calculate the number of purchases. So I'm just going to reuse this in here. Now, notice that the number of purchases uses the price. So I've got to figure out, I've got to pass in the price, which means I have to do it down here too. All right? So we've got the number of purchases. Now, there's a couple of little gotchas, and this is, if you worked through this exercise, the question is, did you catch this? So I kind of leave this open when I teach the class, and you'll see as we go through this series that I won't give you enough information, and that's intentional because, you know, very rarely do you get all the information. The question here is, this transaction cost, do I still have to pay this when it's refunded? Because that makes a big difference, right? And so is the transaction cost for all the purchases or all the purchases that were not refunded? So let's take it as if an app is refunded, I don't have to pay the transaction cost, right? So let's go through here. So we have two different types of cost, right? We have transaction, so I have to calculate the transaction cost. And then I also have, so I'll do it in the right order, I have to calculate the cost of refunds, right? So the refund cost is equal to, let's think about it. So I've got the cost of refunds. It's going to be, all right, how many were sold, right? So how many purchases, number of purchases, right? But I only want to calculate that return rate. So I've got to calculate the return rate, right? So that's the number that was returned times the price, right? So if 5 were returned and I charged $2, that's $10 of cost. Now, the transaction cost, if we're going to calculate this one, right? So transaction cost is the number of purchases minus the number of refunds, right? Because we're not going to count the refunds in there, times the transaction, the cost of each transaction. So cost of each transaction. So it's going to go off the side of the screen here, but we've got it, all right? So notice in both of these, it's good to know the number of refunds. So I'm going to pull out here in our discussion, or in the code here. So calculate the number of refunds. Since we're going to use it twice, I want to get that out here. So number of refunds, and as we said right here, it's the number of purchases times this refund rate. Now, I could just put 0.5 in here and go. The problem with that is this is what's called a magic number or a naked number. It has no meaning. It's 0.05. If tomorrow I come through here and look, I'm saying, what is the 0.05? I have no idea what that is, right? It has no inherent meaning. And so what I would do is I'm going to put it up here. And so I'm going to have a little comment here. So these are our constants. And we have the refund rate is 0.05. So then what I can do is go down here and calculate it like this. Refund rate. Think of this as a sentence. This makes far more sense now. And if I use the refund rate more than one place, and probably not, then I only have to change it here. And the same thing here, we have cost of each transaction, and that's 0.5. All right, so let's go up here and make sure that we've got, we've got it right. So it's 50 cents. All right, so now we've got them in here. All right, so it makes this a lot easier to read. So the refund cost is the number of refunds times the price. And we have the transaction cost. Put this down. So transaction cost is, notice it's the number of purchases. So going back to PEMDAS, we're going to use the parentheses minus the number of refunds times the cost of each transaction. And so then the total cost is the sum of the refund cost and the transaction cost. So we can just add them up here. Cost plus Okay, so this one is a little bit more complicated, and we had some details in here we had to make sure. So before we actually try and test this, let's run through it and see if it makes sense. This is always a good test that you want to do to make sure it makes sense. All right, so we've got to calculate the refund, which means we need the number of refunds times the price. So the number of refunds is the total number of purchases times the rate or the percentage of how often there are refunds. So that's what we've done here. Then we have a transaction cost, which is the total number of purchases minus those refunds, because the App Store is not going to make us charge us on that. And then we take that number and multiply times by the cost of each transaction. All right, so that should give us the total number. Now we've got to come up with some tests. So I'm going to use the same numbers. So we have test costs, and we're going to calculate the costs for $2. All right, so now we're going to have to get in here and check some math. All right, so our costs, so if we've got 1,000, so remember it was 1,000. Okay, so 5% of that, so 1% of that is 10, so 5% of that is going to be 5 times 2. So actually, wait, that's not right. We've got 5%, so 50. Sorry, that's 50. Times 2 is 100. for the first one. Then we have to calculate this. So if we had 50, so that's 950 total number of purchases, or 1,000 minus 50, 950 times the cost. So I'm going to pull up a calculator here real quick, because I want to do this before I run the code. So we've got 950 times 0.5, so that's 475, right? So the total cost for $2 should be 575. Okay, so costs for $2, 575. Question is, does that equal test costs? So let's run this real quick. I got 575. All right, so I'm confident in that one. So now let's try 3. So if we worked up here, we had 700. So we're going to do it here real quick. So 700 times 0.05. So I had 35 returns. Go back down here. So 35 returns at $3, right? So that's going to be 105, right? Now here's the nasty one. We have, so 35 returns out of 700. So we have 700 minus 35. So there were 665 total purchases. I paid 50 cents in the cost. So that's 332.5. So this will total 437.50. So let's see if that works. All right. Again, I haven't proven it works, but I've got some confidence. All right. So each step of the way, we've got some confidence. Now, here's the final one. Let's see if this works. We have revenue minus costs. All right. So now we've got to figure it out. So the revenue was $2,000 for $2. So 2,000 minus 575. So I should get $14.25. So let's see if that works. All right, we got that one. So let's try 3. All right, so if we work back, oh, I've got it right here. We've got 2,100. Whoops. Wrong button. We've got 2,100 minus 437.5 should be 1662.5. Put a 0 as we print it out. All right, so we've gone through all of these and we have confidence that this works. All right, so I'm going to pause here for just a second, let you guys kind of get an idea. Again, I can post this code for you on the Discord so everybody can see. So let's walk through here real quick what we did. We calculate profit, right? So that if we go all the way back up to the top, we want to compute the profit earned based on a price. So we went all the way down here. So here's the profit based on a price. Profit is revenue minus costs. So we went up here and we calculated revenue. And revenue is the total number of purchases times the price. But we had to calculate the total number of purchases, which this is where we did the math that threw some of you for a loop. It's okay. This isn't a math course. It's a Python study series, so we're good, right? Then for costs, there were 2 types of costs. There were costs for refunds, which the refunds is the total number of refunds times the price. Total number of refunds was the number of purchases times the refund rate. And then the transaction cost was the number of purchases minus the refunds. That number we then multiplied times the cost of each transaction, right? So that's how we did all of that. So we calculated, we can calculate now how much profit he does on a given price. Now, ultimately you want to check and see, okay, so what price gives us the most profit, right? Well, we haven't quite covered it. I was hoping to get to it a little bit tonight, but we aren't going to get there. So, but I have some code, and I'm going to put it in here. I'm not going to explain it because it's for later stuff. I'm going to use a for loop here, but I'll post it in there, and it's got comments. So if you work it out, a price of $2.92 results in the highest profit of $1,664.48. So basically, I just went through every cent between in a range here and tested it out. Okay, so I think it's between 50 cents and $6, and this is the best price. Okay, so we don't have enough time to start the next chapter in the book. I don't want to kind of get started on that and then right as we get going, stop. So I'd like to open it up for some questions. I think I've asked all the questions so far, or answered all the questions so far. So I'm happy to answer anything you have in here specifically. If there's something general to Python that's come up, go ahead and ask that now. But again, I will post this on the Discord. I haven't done a whole lot of comments. I've done some in here, but I've tried to make the variable names descriptive enough. And then, as we go through in the video here, describing what we're doing and things like that. It's kind of a case of do what I do, not what I say. But then, I'm doing it live and we're recording it so you can go back and watch. All right. So I haven't seen any question. Oh, here's a question. So Emmanuel asks, so why do we use transaction cost equals purchases minus refunds if the number of transactions should only be the number of purchases? That's a very good question. So let's go back down here to the cost. So the question here is, why am I using this instead of just the number of purchases? So it gets back to, let me go all the way back up here. The question I kind of raised, which I wasn't specified in the problem, is, do we pay the transaction cost when someone asks for a refund, right? So they bought the app. I had to pay 50 cents at the App Store, but then they came back later and said, no, I don't want that anymore. Now, if I still had to pay that transaction cost, I could quickly go out of business, right? A million people could buy it and then say, no, I don't want it. And then, I have $500,000 that I owe the App Store, and I have no revenue because they all refunded it, right? So we went with the generous solution of this transaction cost. If they refund it, then the App Store gives the money back to me, right? So when we calculated the transaction cost, we only focused on the number of purchases that weren't refunded, right? So we did the total number of purchases minus the number of refunds. So we excluded that, basically saying, in essence, the App Store gives us that cost of the transaction back when they ask for a refund. All right. Again, that gets into the weeds, but it's an important point that you have to understand the problem, because if we could have completely ignored that, it wasn't given to us in the problem statement, and programmed it, say it's right, but if it still doesn't meet the needs of whoever wants the program written, then it's not a good program, right? That's a tough lesson for programmers. Is it could be some of the most elegant code and it's just fantastic, but if it doesn't solve the problem at hand, it isn't worth much. All right, so hopefully that answers the question. It all goes back to just kind of a not programming problem, a problem with the problem statement, or a challenge with the problem statement. And that's where you'll find most challenges. It's in the problem, understanding it, and how do you get some of those nuances in and things like that. Okay? All right, well, I don't see any other questions. So I'm going to go ahead and call it an evening here. So thank you for joining us. As a reminder, on Monday of next week, I will post the algorithm for that week so you can work on it. If you'd like, go ahead and post it in the Discord so we can, so I can help you. I'll take a look at it. Everybody else will give some feedback. I'll also note that in the GitHub repository, there for each chapter of the book, I've got some exercises. In the book itself, it's got exercises. And I also have some list of supplemental resources. I've got some other exercises that if you want to work on an algorithm and then try and start implementing it, go for it. Post all of that in Discord. One of the things I don't like about doing the live streams is I miss that interaction with students. So if you're trying to learn this, go ahead and hop into Discord. I love helping people figure this stuff out. So don't be afraid, just jump right in. Everybody's learning something at some point. So thank you again for joining us. Connect with me on the socials. If you do it through LinkedIn, make sure you send me a note what you're hoping to get out of this. And I will see you next week. Have a good week.